whenever we do our u substitution and we get a du over u, right? Or we could think about this as u to the negative first du. Either of those mean the same thing, right? So it's only in this case that I would use a natural log as my antiderivative. If this were to any other power, right? If this were to the second power, I rewrote it as u to the negative second, it would not be a log, right? We would just be using reverse power rule.
The phone is ringing.
Hello. Yes, I did. Sure.
Who is it? Who's in trouble?
Megan. The athletic office at my convenience, she said. So, whenever we're done with the lesson, I guess. So yeah, we would only use natural log whenever we have this specific situation, du over u, or u to the negative first du. Right? So let's go ahead and do number 4 then. So on this one, they tell us what our u should be. Right? They say that make u -1 plus the natural log of 4x, right? Which is what we see right here. So if I say u equals -1 plus the natural log of 4x, and I take that derivative, du, derivative of -1 is 0. Derivative of natural log of 4x would be 4 over 4x, which would just be the same as 1 over x dx. Right, but if we look at what we have 2 over x, right? So I would want to multiply both sides of this by 2. So I would end up with 2 du equals 2 over x dx. So now I can do my u substitution and say this would actually just be 2 times du over u. So since this is a fraction, that's probably where that messed people up, right? We've got 2 over x, but we're defining 2 over x to be my du. So that would actually just go in the numerator. My du over my u. So this is the case where we have a natural log. When I take the antiderivative, we would just have 2 times the natural log of the absolute value of u plus c, and then plug the u back in. So 2 times the natural log of -1 plus the natural log of 4x plus c.
What threw me off was I didn't know we could put a natural log in a natural log.
Sure, yeah, you can do that.
Because then I plugged it into my calculator. I plugged a random number in brackets. I'm like, it's saying I can't use it.
Well, did you include absolute value bars? Then you probably plugged in a number that resulted in a negative value inside the log. 3, sure. So this one is like that final example we did as the bell was ringing yesterday. So here again, they tell us what our u should be. So u is 5x to the 4th minus 2. My du then would be 20x cubed dx, but I want it to be 80x cubed dx, so multiply by 4. So 4 du equals 80x cubed. Now if I do my u substitution, we would have 3 to the u times 4 du. Now when I take my antiderivative, I will have 4 times the antiderivative of 3u du is just going to be 3 to the u, but then over the natural log of the base. Right? Because if I take the derivative of 3 to the u, that derivative is 3 to the u times du times the natural log of 3. So when we're going backwards, right, if there isn't a natural log of 3 here, we would have to divide by natural log of 3. And then plus c. So plugging my u back in, this would just give us 4 times 3 to the 5x to the 4th minus 2 over natural log of 3 plus c. Is that a question or a scratch? What other questions do we have?
5.
8 and 5.
And 7.
Alright.
But I only have a question on 5 because I got it wrong by, I don't know why, but u was multiplied by 2 in the answer. I don't know why.
Okay. So my u, I'm going to make x cubed plus 2, right? Because 12x squared would be a multiple of its derivative. So my du then is 3x squared dx, but I want it to be 12x squared.
So multiply by 4.
Multiplied by 4. So 4 du equals 12x squared dx. Do my u substitution. So I would have 4 du over u. So the antiderivative of that would be 4 times absolute value bars, 4 times the natural log of the absolute value. Let's see, which would be 4 times natural log of x cubed
Yep,
plus
but
2.
Yeah.
Your answer says 4 ln of 2x to the cube plus 4 plus c.
Yeah. Look at that. No, because you still have the 4 out. Stop looking at it.
What's that? Yeah, that must be a typo then.
Okay.
Yeah.
So I was good anyways. Okay.
Alright, so
7 and 8.
7 and 8. So on 7, we've got, generally, our u is going to be the exponent whenever we have an exponential, so I'll make my u cosine of negative 2x. Then my du, derivative of cosine is negative sine. Right? So this would be negative sine of negative 2x times negative 2. Right? So I'll go ahead and put that out front here. I'll have a negative 2, which would end up just being positive 2. But I want it to be 10 sine of negative 2x dx. So I would multiply both sides by 5.
I know why I do.
So we just get 5 du equals what we want. 10 sine of negative 2x dx. Then we can do our u substitution. So we'll have e to the u times 5 du. And the antiderivative would be 5e to the u plus c, which would be 5e to the cosine of negative 2x plus c.
I think they should put parentheses where parentheses are needed.
Yeah, I mean, I always like to put parentheses, but
Because that makes sense now.
I mean, on the AP test and a lot of standard notations, they don't put parentheses around things that are inside of a trig function. I mean, I prefer to put parentheses, but a lot of things don't. So
Because I thought it was just minus 2x. I'm like,
so then number 8, again, my
quantity.
exponent will be my u. If I take the derivative, du, Derivative of negative 3 is 0. Derivative of natural log of 3x would be 3 over 3x, which would just be 1 over x. But I want it to be 5 over x. Okay, so multiply both sides by 5, and we would get 5 du equals 5 over x dx. Then we can do our u substitution. So we would just have e to the u times 5 du. So antiderivative would be 5e to the u plus c, would be 5e to the negative 3 plus natural log of 3x plus c. Now, on a multiple choice question, they might simplify this sum. And I mean, this is perfectly fine for the end of a free response, but I would venture a guess that they would split it up like this. And what's e to the natural log of 3x?
1.
3x, right? E and the log base e would cancel out, and then I could just say this is 5 times e to the negative third times 3x plus c, which I could even simplify to 15x over e to the third plus c. Oh no.
No complicated crap.
So, I mean, this is fine to end here for a free response if you're just showing your work, but on a multiple choice question, we should feel comfortable with the algebra to get to that point. I mean, the goal is to learn the calculus concepts, but we still need to be able to do the algebra as well.
No, it can work with
Any other homework questions?
that. Yeah,
Feel okay with this stuff? Alright, then today we are going to do definite integrals with no substitution. So, this is what you asked about the other day.
and you shall receive.
So, let's do 0 to 2.
Press.
Gotta take your own notes. I did not make a note sheet because I'm just gonna make up a bunch of problems as we go. So let's say yes. Okay. So we should feel comfortable taking the antiderivative of something like this using u substitution. The only new thing that we're throwing on there today is making this a definite integral, putting bounds on the integral. Okay? So our first process is still going to be the same. To recognize a u, find our du, set up our integral. Right? So what would my u be in this case?
X cubed plus 4.
X cubed plus 4. Right? So we'll say u equals x cubed plus 4. My du then would be 3x squared dx.
Multiplied by 1/3.
Right, but I just want it to be 1x squared. So I would multiply both sides by 1/3. So we get 1/3 du equals what we want, x squared dx. So now let's do this u substitution part. Over here. So how would I rewrite this in terms of u now?
It would be du over u.
Yeah, we could write it as du over u cubed, or u to the negative third du. Right, don't forget the 1/3. Now the new part, okay? What do we do with these bounds? And what we want to do is rewrite these bounds in terms of u. That means I'm going to evaluate u of 0 and u of 2. I'm just going to plug each of my bounds in to whatever my u is. So if I evaluate u of 0, that's going to be 0 cubed plus 4. So my lower bound, when I do my u substitution, becomes 4. Do the same thing with 2. Plug 2 in, so 2 cubed plus 4 is 12. So my upper bound now is 12. So now, we would go through the same process of taking the antiderivative here. So what's the antiderivative of u to the negative third du? You want to have u to the negative second? And now, since this is a definite integral, I don't put plus c, right? We just want to now evaluate this from 4 to 12. Since I changed my bounds to fit my u substitution, I never have to plug my u back in now. I'm just going to plug 4 and 12 into this. Okay? I don't have to plug x cubed plus 4 back in ever. So what this would become is negative 1/6 times 12 to the negative second power. So that's my f of b. Minus negative 1/6 times 4 to the negative second power. It is ugly, right? Since I was coming up with this off the top of my head, it works out to be a pretty ugly fraction. Right? But remember, if this is a free response, stop there. You do not have to go past that. Once we have all numbers, once we have a numerical value, not have to do any more simplifying. Okay? So with something this ugly, okay, it's probably going to be on the calculator portion. Okay? But if not, if it does happen to be on the non-calculator portion, stop there. Do not try to do anything else. Okay? So we okay with this idea so far? All right, let's try another one. About the integral from 0 to 1 of 4x times e to the x squared plus 3 dx. Plus 3, yeah, x squared plus 3 is the exponent. 2e to the fourth minus 2e to the third. Alright, so the only new thing that we're doing today is saying, well, we got to change our bounds too now. We do a u substitution. So we just plug our old bounds into u to get our new bounds, and then we never have to worry about plugging u back in. Why don't you guys try plus x minus 3 to the third power from 0 to 2. Yeah, that should work. Try this one. Yeah, the u will be the x squared plus 4x minus 3.